Thanks for joining us at the end of this learning track, this session. Out of curiosity, how many people were with me in Dev 10 to kick off the learning path? So quite a few hands, that's awesome. How many people stayed in the Dev learning path, the Cloud Apps path, all day? Okay, so quite a few of you. So this session definitely doesn't require it, but it will build on some of the concepts that you saw in the other path. And we're going to talk about the exciting topic of serverless, which, contrary to popular belief, is not no servers. We're going to find servers in the talk, I guarantee it. But it is less servers and more code that we'll dive into. The first thing I want to do is serverless is one of those terms that you hear thrown around a lot. And there's no central body that's taken ownership over we're the official definition of serverless. So I want to talk about some popular definitions, some thoughts around what that is so we're on the same page with that, and then we can certainly have dialogue about that later on. But I like to think of serverless in the context of an evolution. So I've been in the IT industry for 25 years now, and I was very much on the side of the industry that we were physically configuring boxes, putting them in data centers, and answering a lot of questions as a developer, which is what I love to do. I didn't want to answer. Some people love doing this type of thing, but discovering how to configure an uninterruptible power supply or having redundant power were just some of those things I wasn't interested in. And so what was nice was when infrastructure as a service came about. And this is the concept of using your physical hardware and being able to run multiple images on that hardware. And this reduces the surface area of questions quite a bit. We're basically no longer responsible for the hardware, we just worry about the operating system and everything on top. Still quite a bit of responsibility. There's things like keeping that operating system up to date, as well as applying patches and installing dependencies. But I think the two great things that happen with infrastructure as a service is, number one, it helped reduce some of the waste. So where we used to have banks of servers sitting by just waiting to be turned on in case something happened because we didn't want to get stuck if the customer suddenly raised demands. Virtual machines give more flexibility. We can have multiple images running on the same hardware host, for example. The second thing it did was pave the way to be able to lift your virtual image and put it into the cloud and start to run it on other people's hardware, basically pay for the service of someone else worrying about the hardware, the security, the access, and you just focus on that environment. Another evolution of this platform, something that Microsoft jumped in pretty early on, was this concept of platform as a service. And if you were around in the very early days of Azure, there was a very .NET-centric version that provided this platform that took away the need to have to manage an operating system and took away the need to have to manage the dependencies, and you can focus on code. And that's where platform as a service is today, whether it's a database platform or a code platform. I can take a Node.js app or a .NET application, deploy that application, run it, scale it, have multiple instances running, and I don't have to configure Internet Information Services anymore. I can take that big block of my life that I had to learn how to troubleshoot, IIS, and push it aside and focus on what I love to do, which is code. So platform as a service, take the app, place it on the platform. Everything platform and underneath is being managed. And again, we also reduce the amount of waste because now you could have multiple instances if you wanted to running on the same hardware and you're maximizing your use of what's going on. So serverless is the tail end of this. Now, I like to say, how do I architect my app? That's a pretty loaded question though, right? So the answer could be the rest of this hour explaining it. But the idea behind serverless is taking it a step further and not even worrying about the web platform. So I can think about serverless in a number of ways, and we're going to see different approaches, but I can think about it as a piece of code that runs for a reason. And that reason might be that a timer went off, or that reason might be that I dropped a file into file storage, or it may be that someone made a web request to an endpoint. But I just focus on that code and that reason, and the infrastructure handles the rest. We'll see an example of that. It might be something like messaging. It might be something like integrations. Give me an easy way to integrate different services and resources that are on the cloud so that I don't have to go through and manually build boilerplate code to connect to another service, for example. So when we think about serverless, I like to think about three key things. The first is that the server is being abstracted away. But that's something that's been going on for a while, right? We've seen fully managed services, so that's not new for serverless. This idea of event-driven and instant scale is important because the way the architecture is designed, you can scale out very quickly and respond to demand. So that's a benefit and a piece of what it is. I also think, and this is an opinion, this is not a certified, here's the official definition of serverless, but I like to look at micro-billing as sort of a gut check on whether it's serverless or not. If you're only paying for what you use, what drives value, I think that's a good case for serverless. If you're paying to keep something up, regardless of if you're using it or not, then I would call that fully managed and not serverless. So focusing on that cost, for example, there's an offering called Functions, and in serverless functions on the Azure platform, you have 1 million executions that you're not even billed for in the month. And it's based on as much memory as is consumed over time as well. But in this example, if I have a piece of code that takes up about 128 megabytes of memory, runs for a second, and does that 1 million times in a month, I'm not even billed for it. If we feel like it'd be more realistic to multiply that to 5 million calls per month, that goes up to about $4.40 US. So it's a very low cost because we're not paying for it to just stand there. This is something I tweeted, which is sort of the set of tests I look at. One of the things I believe is serverless should be cloud native. It should be able to run in the cloud. Doesn't mean it has to. We want to be able to run and debug and troubleshoot locally, but it should be able to exist entirely in the cloud. I don't want to have to run and scale by configuring virtual machines or clusters. And this doesn't mean that Kubernetes, for example, is bad. I just wouldn't consider it serverless because there's a lot more to it. We're not abstracting the servers away in that case. And then do I only get billed for active invocations? So containers are something that I get a lot of questions about. Well, how do those fit into the big picture with serverless? And it's not the answer that people are looking for, one is better than the other. They're different uses and different tools. And in fact, there's customers that have containers in use that are also using serverless because the workloads are different. For example, if you have legacy code with a lot of dependencies that might not be supported by serverless, a container might be a great way to package that up and scale that and take advantage of that. If you need something like auto scale, if you want to just bill per use, so you have a very elastic system that sometimes there's very idle usage, sometimes it spikes, serverless might be something to look at because it can do that elastic scaling on the fly. And we're going to see an example of that, by the way. This will involve live code and live demos on the web, so I don't think anything could possibly go wrong, right? So let's look at a scenario with Tailwind traders. Someone is requesting information about a SKU. Pretty simple operation. Now, this question might come from a website. It might come from a store that someone's scanning information about. We have a few requests come in and everything's fine. But what happens is, let's say we run a sale or we have a new product. Then suddenly we get this massive load and suddenly the server is not enough. Now, I've been in those companies when we didn't have this available that we would onboard a new customer and have 8 servers sitting just waiting for that workload because we didn't want this one server to die. What would be really nice, though, is if this could happen automatically. And based on that demand, the servers could scale out for that. So the first thing I want to show you is just a quick example of how serverless manages this. And what I'm going to do is drill in to a serverless application I have running. And if you were in the telemetry session, you learned a little bit about application insights. If not, when I create an Azure function, I check a box and automatically get telemetry, information about how the health of my service is running. Actually, all my serverless services. So I have this live metric stream, and what this will do is it'll live show me the activity that's happening on my serverless endpoint. So I'm not concerned about outgoing requests or overall health. I've basically got a chart up here that's not doing anything because nothing's happening. And then I have this, which is showing me that there's one process that's sitting waiting for something interesting to happen. So I'm going to take this endpoint, and I'm going to go ahead and paste it. And what this is doing is it's doing a simple fetch of some SKU information. Now, before I show you the code, I want to pop over and show you that I got a request here. And this one took a little over 400 milliseconds. So a little bit slow because it's been idle for a while, so there is a little bit of startup time. If we look at the code for that endpoint, I've got a serverless function that's a GET, and I'm not writing a controller. I don't have to be tied to web for this. This particular function, I'm telling it when you get with a SKU, I'm giving it a template, then this is something that I want you to trigger this function. It's going to automatically parse out the route for me, and it's going to give me a handle to a table and some logging. So what we'll do is we'll come in this particular case, we're storing it in table storage. So this is retrieving it from table storage. If it gets a result, it's going to log it. If it doesn't, it'll say not found. So very simple method. That's all I focus on as a developer. All of the infrastructure and web is handled by the functions runtime for me. So what that means is we can do something like this. We can come back, and I'm going to just grab this so you don't have to see me fumbling on the keyboard. And what this is using is a node utility called artillery that's going to generate some load for me. And what I asked it to do, now this will be throttled from my laptop, of course, on conference Wi-Fi. But we're going to go ahead and try to mimic 100 users making 100 requests to that same endpoint. So I'm just going to kick that off. And this is one of those areas where live demos, what could possibly go wrong. Suddenly you can see that we have this huge spike of requests. This is 100 per second. And look what happened down here. Now we've got multiple servers servicing the requests, and we've actually scaled out to multiples. So if we look at this, we're accommodating more load per second. Our requests slowed down a little bit until it figured out that there was a problem. It spun up more servers. Now our requests are returning quickly, and we have the services that are available to handle that load. And this will run for a little while, and it'll eventually trail off. We can come back and see all the success codes coming in. That's these 200s. So it's going to take some time. I'm going to go ahead and stop it because it actually finished. So that's 10,000 success codes getting that SKU. Now these extra servers are going to hang out for a little while just to make sure that spike doesn't happen again, and then they'll eventually drop out. Now what's important to note is when you saw those servers spin up, I'm not paying for servers. That's not in my contract for functions. I just pay for every time a function's called and how much memory it consumes over time. And then if it requires 10 servers or 100 servers, that's handled by the host system. What I just showed you is a piece of the Azure Serverless platform called Functions. And functions, I'm going to dive into them a little bit more, but they're basically code that responds to events. There's also a piece of the platform called Logic Apps. Logic Apps are integrations. If you've worked with BizTalk, it's very similar, but it's a cloud-native version that's designed from the ground up to integrate different resources and allow you to have workflows and take steps, and we're going to see exactly what that looks like. There's another component called Event Grid, which is for messaging. If I want to send messages between applications. I've done this in my career where I've had to stand up the infrastructure to send alerts and messaging, and that can be a very onerous process and require a lot of resources. This is a serverless process that allows you to publish and subscribe to messages, and it scales based on demand for you. Now, the important thing about these components is they all interact with all the pieces of an application that you'd ordinarily interact with. They can interact with databases, storage, Internet of Things, analytics, intelligence, you name it. And even more important to me is that they're part of the development toolkit. So I can develop these locally, I can debug them, I can troubleshoot them. With functions, I can even execute functions without having a connection to the internet. There's a full local runtime that's cross-platform, so I can develop on Windows, Mac, or Linux with the same experience from that. So to hone in on functions a little bit, if you've seen the logo for functions, I'm about to reveal a secret that I hope we can let out of the bag because there's a lot of people in this room. But it's code and events, and that's where the logo came from. So now you know something new. If that's all you take away from that, I'm sorry. There's more, I promise. Just to give you an idea of the maturity of the runtime, there's 40,000 active customers, and this is growing. These are numbers from earlier in the season. Over 250,000 apps, but what I think is critical is that the infrastructure is handling about 3 billion requests daily, and that's growing continuously, and that's on average. There are times, for example, you can imagine when there's retail events that spikes and goes significantly higher. So one of the pieces of secret sauce about functions is this idea of triggers and bindings. And if we go back to the code, this is a trigger. This is what caused the code to run, and we'll look at other types of triggers, and there's multiple triggers. This is a binding. This binding says I want to talk to table storage. And so what's nice about these, you can see we have several, and this is not the full list. What I can do is, with very little ritual and ceremony, specify that I want to work with a resource. I want to work with Cosmos DB. I have a personal application that stores data in Cosmos DB, and the way it does it is it builds up an expando object, a dynamic object, puts the properties it needs, and returns. That's it, it's done. That gets inserted, and all that is handled for me by the triggers and the bindings in that function. So it can help accelerate the development lifecycle. And we've got triggers that cause it to run, bindings that allow us to work with resources. So some of the things you can do with serverless, you can run a timer that might parse a table, clean invalid data, and leave you with a clean table. Maybe you're keeping web session information, and you just want to purge that out. And instead of installing a scheduling service or a Windows service or a cron job and doing that, you can just have a timer, little piece of code that does this, and you're done. We might have an example where I upload a file to storage. That file happens to be a comma-separated value file. So we have a piece of code that says, oh, there's a new file, let's parse it, transform it into actual rows in a database, and then we can stand up analytics on the back end. It's another scenario. There's a scenario of taking a picture, you store the full picture in the cloud. This triggers a process that goes through those pictures and generates thumbnails automatically. And it's the uploading of the photo that's the trigger for that process to kick off. And then this is my favorite one. You visit a web page, all of the private data that's been collected around you over the years goes into a database somewhere, pulls out, and gives you that lovely customized completed page with an ad just for you, tailored to your interests. We love that. So a few case studies. This is an example of a customer who is using functions to onboard custom business rules for customers. So that as they come on, they create functions that trigger and process these rules, which is a pretty unique use case. Another customer, just by taking advantage of the workflow with not having to be in the business of managing servers and rolling manual connection strings using triggers and bindings, basically from a week down from 4 months to do the same piece of code, which is pretty powerful. Now we'll look at functions a little bit more, but I want to segue into Event Grid. Now this is something that's very ubiquitous, right? We have events all over the place. The vending machines out in the hallway probably generate events and let the vendors know that they're low on supplies. We need to do things. If you've ever had to manage events across an enterprise, it can be pretty cumbersome. I've definitely done that several times in my past. So the idea behind Event Grid is to manage them in a central location and do that in a serverless fashion. So what do we mean by that? Well, there's fully managed routing, which means I get a message from point A to point B. I make sure that it traverses where it needs to go. This is near real time at scale. What does that mean? I will get into specific numbers in a minute. Broad coverage in Azure and beyond. This will work seamlessly inside the Azure ecosystem, but it's designed to work outside of Azure as well. So third-party apps, even if you're hosting on other cloud providers, it can connect into Event Grid and take advantage of that. So this is the backbone of events if you choose to go for that and control them from one centralized place. Now the idea here is that, again, instead of investing time in the infrastructure and the scale out, you can just focus on the messages, let the infrastructure deal with the rest, the reliability, performance, and the more time you focus on what's unique to your business, obviously the more time you can innovate, which is at the end of the day what companies want to do. By far, I believe the biggest benefit of Event Grid is being able to manage all these events in that centralized location. Has anyone here worked with event hubs at all, out of curiosity? So I see a few hands. What about Service Bus? A few more hands. So there's always this question, how does this compare to these services? I wanted to look at that just really quickly. So Event Hub is what we would call point-in-time data. And what I can do is I can get a stream of like a big data stream, if you will. And I can go out and I can query a segment of that data stream and find out information. So it's very much a pull model. So it's aggregating information, I go out and ask for it. If we look at Service Bus is more a queue and a way of routing business logic. It can do things like handle transactions and commit things and route things. So it's a very advanced workflow that makes sense for those scenarios where you need that functionality. Event Grid sits in the middle. It's really designed for business logic. It's as things happen, you're notifying other processes and applications that something happened. And it's going to handle the routing and move things around. But what's really key is you never ask Event Grid for an event. You don't go out and say, give me an event. Event Grid always delivers the event to you. You have a handler that's ready to receive it, and then Event Grid guarantees that it'll deliver to that handler, provided you can keep it up in a 24-hour period. If you can't get your handler working within a 24-hour period, there's a place that can deposit events so you can process them later when you get up and running again. So having said that, the scenarios Event Grid is good for, first is serverless apps, which we're going to show a serverless app that's using messaging to build out scale points. There's a very intriguing case study. This isn't my area of expertise, but with ops automation, we can trigger certain types of events that can do things like cause Azure runbooks to run, or trigger a PowerShell function that does some scripting. So it can automate events in infrastructure based on those messages that are being produced. And then there's the piece of integrating applications, even legacy applications, into a bigger system. How do maybe I'm migrating from my legacy system to a new database, a new architecture, and I need a way to keep them in sync. And if I can actually post to an HTTP endpoint from my old application, I can send an Event Grid message and consume it in my newer application. So if we look at the left side of the screen, these are places events take place. They're the source of events. Most resources in Azure will automatically publish Event Grid events. If you're not listening to them, then it doesn't matter, but they're there for you to listen to if you're interested in it. But the other thing is you can create your own custom events, so you can source events that aren't part of Azure at all. And on the right side, when that event's delivered, there's many resources in Azure that know automatically how to take an Event Grid event and do something interesting with it. So they can pick it up and respond to it. But on the same token, if you have your own application platform library, as long as you can receive an HTTP post, then you can receive an Event Grid event that can be handled through the webhook standard. And it's really as simple as going in and creating a subscription. You can do this from the command line or in the portal. You basically, when you create a subscription, what you're saying is, this message needs to be delivered to this handler, and that's it. We name subscriptions in case we need to unsubscribe them later. Every route is going to have a subscription, basically. So I told you what near real-time would be defined a little more specifically. This is sub-second end-to-end latency. So it'll take about a second to deliver, even with big scale and a lot of messages coming through. If you're doing a conveyor system that scans an item and has milliseconds to route it someplace else, this is probably not the right system. It's not going to respond quickly enough. But if you're getting applications to talk to each other, raise interesting events, and receive them, then this is near real time. Usually about a second latency is good enough for most business processes. This will handle 10 million events per second per region. It'll do a 24-hour retry, but again, if it can't get delivered within the 24 hours, there's an option to have a dead letter queue that it deposits so you can pick it up later. And then you have 4 nines availability, 100 million subscriptions per region, and it does all the failover internally for you. Having said that, before I jump into a more specific example, just want to recap on the terminology. So the event's what happened. It's not something should happen, it's what happened. We can react to that, but that's the idea of the event. The publisher is where it took place. The topic is like a channel, so you can group similar events together. So if I have a blob storage account, maybe I have different events like add a file, delete a file, modify a file, but I want them in that same channel. I'm interested in things about blob storage. The subscription is how you receive events. It's how you say, basically, I want you to deliver it to this endpoint. And then the handler is what actually processes the event. It's what gets the event and ultimately responds. So in our Tailwind Traders scenario, we can add new SKUs to our catalog. And maybe we get a list of SKUs here, and we have another process that prices them, and we have another process for setting up descriptions and images. So I might get that add event that comes in, and then I might get a separate event for setting the price, for example. So it's a pretty simple scenario. I add a SKU, I can set the price, set a description or whatever, and then eventually when it gets everything in place, it can go active and be an official part of my catalog. So what I want to show you is a first step of wiring up Event Grid to Azure Functions to show you how those are consumed. So I'm going to come in just to make sure you're not watching me fumble and type, and grab this. So I have a command line tool for doing the SKUs. This could easily be a web portal. It could be a mobile application, however you want to source that. And I'm going to come back into my dashboard and just drill into the Functions app. And to wrap your mind around function apps versus functions, a function is a piece of code that runs in response to an event. A function app is a point of scale. So you can have multiple functions in a function app, but when it scales out and spins up new processes, it's going to scale the app. So those endpoints go along for the ride. We're going to go into this simple monitor function. And if I go into the function inside the portal, I can come down and open up some live streaming logs to see what's going on in real time. Now I'm going to show you the code for what that monitor looks like. This is just another function, only this time it's triggered off an Event Grid trigger. So that's what's causing this function to run, and I'll show you how we subscribe in a second. And it just logs the event that happened. That's it. It's a very, very simple endpoint. So this turns out to be an incredibly exciting demo because what I'm going to do is on the command line, I'm going to add a new SKU. What this is doing is going into table storage, storing the data for the new SKU, and then it's raising an event. It's saying, hey, SKU is added. So if we come over to our monitor, we can see that we indeed got an event. And it gives us some information about that event. The event type was added. And the payload of that event was a SKU with the SKU number. So that's the data of that event that we got. Now, if we look at the next step, what I can do is set the price. So I'm going to jump over here. And so this is the same CLI application. This time I'm just setting the price of the SKU I just added to $9.99. Purposely leaving that open-ended so we can call it euros, right, where we're at. So it raised the event, and this time we can come back over, and we can see that there is an event. And this time the event has a little bit different piece of information. It has a price and a SKU in it. So it has two pieces. The data inside the event can differ from event to event. The way I raise those events is I use the Event Grid SDK. This is the actual code that raises an event. So I have a type in of an event and the item. And what it's doing is it's creating this event, giving it a unique ID, a type, putting the payload in, which is SKU or SKU and price, for example, giving it a date, a version, throws some credentials in, and publishes it. Now, this is using the SDK, which just makes things easier. You can do the same thing if you can do an HTTPS post. You can set authentication in the header, roll your own payload, and post it. So you don't have to use the SDK. Just scroll this down. The other thing I'll show you is when I created this function, I used an Event Grid trigger. So it's smart enough in the portal, and you can do this from the command line too, to realize that this needs a subscription to route something to it. So I would click on this Add Event Grid subscription. This is going to let me give it a name, basically drill down to the topic. There's a lot of different topics. And then I can pick, once I know what topic I'm looking at, if there's specific event types I'm interested in, and it automatically knows that it's going to post to this endpoint because I'm inside of a function. But this is it. I fill out this form, I click Save, and the subscription's created. I can go into my dashboard and search for inventory is the name of the Event Grid topic I created. And this is as easy as hitting the plus, saying I want a new Event Grid topic, giving it a name. It'll give you an endpoint that you post to, that's over here, and it'll give you a key so that you can manage access to that endpoint. But this will come through and show me a boatload of subscriptions so I can look at activity and things around those. And if I drill into them, there's other metrics I can see about rate of subscriptions coming in and everything else. So this is all surfaceable to what you'd want to track. So that's interesting that we were able to just echo an event. But it's not very useful for us, right? So what I talked about was a couple things. The first thing I said is serverless is build based on number of times it's called and how much memory it consumes over time. So if you think about that, that means processes that take a long time to run or processes that use a lot of memory can be much more expensive in the serverless model. And that can help you decide if a workload makes sense. But what's interesting is a lot of times your workloads might take a long time to run because they're spending most of their time waiting on something. So I may asynchronously be calling out, waiting for a response. And if that response takes a long time, normally I would get penalized for it. Durable Functions is an extension to Azure Functions that allows me to have long-running workflows, and it's only going to bill me for the time that workflow is active. So when we talk about stateful workflows, when I'm waiting for something asynchronous, it's going to preserve state for me, wait for that asynchronous event to finish, and then restore the state and continue running. So I put it on hold, I'm no longer billed, I no longer worry about it, it comes back. So my compute time is short, even though time on the calendar might be longer for that process to run. It does this through what's called checkpoints and halts, which we would take a full session to dig into the details of that. I'll have some resources online for that. But what's really neat is the patterns that you can do, things like asynchronous sequential calls. So I need to respond, but I'm waiting on something in the interim. So let me grab this. There's fan out and fan in. This is the one where I'm doing a search engine aggregator. So I send out a search request to Bing, I send it out to Google, I send it out to Alta Vista, Lycos, Dogpile. Now I'm showing my age. These are all old engines. And then we get the results, we pull them back together, send them to an endpoint. Maybe I have a process that I'm waiting for human intervention. So I need to escalate this, and I need someone to push a button. But if no one pushes a button in 72 hours, I want to raise it up to the next tier automatically, so it's not left undone. That's an example. And then ongoing monitoring functions. Maybe there's just a life cycle of something that I'm checking, and I want to look in, is it done yet, is it done yet, is it done yet? All of these can be handled. So in our example, I add a SKU, I set the description, set the image, set the price, and then that SKU is done and we can set it to active. So I need 3 things to happen that don't necessarily happen in order, and then once those are done, we can mark it active. So the way I do that in code is like this. I've got another endpoint, another function called process. Now what's important about process is it's that same event grid trigger, so I'm not having to change my initial application. The CLI is still the CLI, it still raises the same event. I can just write other code that responds to the same event. So this is going to grab an event, and it's getting this binding called orchestration client. This is how we kick off the long-running workflow. So what we'll do is we'll come in, and if it's added, we start a new workflow. That's what this is saying. Okay, there's a new SKU in the system. Let's start watching this SKU. What this is saying is otherwise, look for the existing workflow. So this is going out and getting, there's already one running. And then tell that workflow that something interesting happened. So it's saying, hey, we just set the price. Let me tell that long-running workflow we just set the price. The workflow itself looks like this. This is the entire code for the workflow. Basically grabbing the SKU, I have 3 events I'm interested in, so I'm waiting for an external event, and then I await when all. This point in time, without me doing anything else, Durable Functions automatically preserve state, says, okay, we're gonna wait for these functions, these events to trigger. When they do, we'll pull state back in, and we'll continue running, and when all 3 run, it's gonna follow through and mark the SKU active. So we can take a look at that by jumping in, and I'm gonna grab a copy paste for another workflow here. So this is the SKU that I just added and set the price on. What I can do is I can run a get to that and just tell it, what information do you have about the SKU? And this is going to process the request. I've got a price, description's not there, image is not set. We can also look at this with Storage Explorer because I'm using a storage account. And if I refresh this, we can see there's 5 rows here. I'll refresh it. Now we can see here's the SKU that I added, this 2181. There's no description, no image URL, price is set, and if we scroll over to the side, we can see is active is false. Price is the only thing that's set, so that's the only interesting thing that's happened so far. So what I'm going to do is come back over here, and I'm going to go back into my functions, and this time instead of monitoring the monitor, or even the process, because process just kicks off a new workflow, I'm going to go into the SKU workflow and go into this monitor. Actually, I'm going to open this and scroll down to the logs. So we're in the SKU workflow. I just showed you the code for that. We're going to expand these logs. And then what I'm going to do is grab this piece of code to add a description. So we'll come down here. We'll paste that. And again, this has no idea that I created this workflow. All it's doing is adding this subscription, raising an event. This code is open source, so you'll be able to pull it down and see for yourself. If we look at our monitor, we should eventually see it come in and wake up right there. So durable function started for SKU 2181, and it's done because there's nothing interesting. It just received the event, but it's waiting for multiple events. If I look at my storage and I refresh it, now I have a description, and we're going to see another flag set to true over here. So let's grab the next step, which is going to be to upload an image. So what this will do is it'll grab an image off my laptop, upload it to blob storage, and then store the URL in the table. So here's where the image is stored. And of course, it will raise an event as well. So I'm going to clear this. We'll jump into that step. Added the image, uploaded it, raised the event, everything's good. So we'll pop over to our monitor, and our monitors basically said all events received, marking it as complete. So it woke up, marked it complete, and now if we run our get command from earlier, we can see the item is active, and we can even look in our storage, refresh that, and see our workflow is now set as active to true over here. So that was a long-running workflow, and again, the code for this was pretty simple, and the runtime for this function was really light because it spent most of its time just waiting for the other actions to happen. That's one example of the serverless workflow. Last piece of the platform is integrations that I want to show you. There's actually other parts of the platform, but we could do a day-long workshop and drill into everything. But Logic Apps are pretty powerful, and I want to make sure people are aware of them. Is anyone using Logic Apps today, by the way? So there's a few hands. Is there anyone who did not hear about Logic Apps before today, out of curiosity? Okay, a few hands. I can actually see it through the light. That's great. So what Logic Apps do is they connect things together, but you can make decisions and have workflows for it. And I'm not going to talk about it too much because it's easier said, actually seen, than done. So actually easier done than said. You'll see it in action. There's hundreds of connectors. This grows every day. I stopped trying to have a chart of connectors on the slide because we keep adding these connectors. There's a visual workflow designer. The details don't matter on this. We'll look at something more closely. But what's really neat is in addition to connecting things in the cloud, so I can connect things on the Azure side to things like Office 365, even third-party services like DocuSign, I can also run a gateway on premises and connect with processes inside my firewall. So I could have a workflow, for example, that's kicked off in the cloud that results in a stored procedure, for example, being run inside my secured SQL server. It's inside my data center. Now keep in mind, I'm controlling that gateway, so it's not open to the world. It's based on that workflow. So we have a customer that onboards customers more quickly because they're able to just pin together Logic Apps to do those integrations for the onboarding, which is very beneficial to them. But I want to show you what this looks like in real time. So what I'm going to do is I'm going to reuse this same event. This is what I love about event-driven architecture, is you can start expanding your application without going and rewriting everything else. I don't have to go to my command line tool and make it call another endpoint. It's already raising the event, so I'm going to take advantage of it. So what I want to do is create an integration with Office 365. So when that new SKU is added, it will email the team and tell them there's a new SKU, so they need to know that they're going to go set a price, get an image, do all those work steps. So it's just informing them. I have a lot of different ways I can kick off this integration. I'm just going to pick when an Event Grid event occurs. So that's going to be my trigger to kick it off. The same way I have triggers for functions, I have triggers for Logic Apps. So I've already authenticated, so it's good to go with the Event Grid. Now I need to tell it what event am I interested in. So I'm going to tell it basically out of the millions of subscriptions I deal with all the time, we're doing Ignite the Tour. There's a resource type. Now these are all the different ways Azure natively raises events. I'm going to go into topics. These are the custom events that I create myself, and then it's the inventory topic. Now, the only thing that I'm interested in to listen to is the added event. We have a price, we have an image set. I'm just interested when it's added. That's when I'm going to send the email. So I'm going to use this as the filter so it only triggers on added, and that's all I need to do for that step. So now I'm going to pick a new step. Now remember when I showed you the Event Grid payload, that payload can be different for different events. So it'd be helpful if I could describe the payload I'm expecting to Logic Apps. So what I can do for the next step is I can do something called parse JSON. And what parse JSON lets me do is exactly what it says. It parses out that payload and gives me a schema. So when I click in this content, what it's doing is it's remembering all the previous steps. So it remembers I had an Event Grid event, so it's giving me all the possible options of what I can pull off that Event Grid. So I'm looking at the data object. That's the main payload for that event. Now it's asking for a schema. So what's really nice is I can paste the sample JSON and it'll generate the schema for me. Or I can go over to my cheat sheet. And if we scroll to the right spot, I can copy and paste it. So what I'm saying is expect it to be an object that has a single property on it, and that property is a string called SKU. So I paste that schema in, and now I've described what my payload looks like. So now it's time to send the email. So I'm going to do new step, Office 365. And what I'm interested in is coming down here to send email. We'll go send an email. It says, okay, you want to send an email. Who are you going to send it to? So I'm going to be a little bit risky. Let's jump over here so my inbox is empty. I'll just go ahead and do my personal email. Now everyone knows it. We're going to do a subject, and I'm going to say, hey, a new SKU was added. So what is the value of the SKU? That's where, because we parsed the JSON, we can just grab this and tell it, grab the SKU out of the Event Grid payload. Then the body of the email, I'm going to say, by the way, this was added on, and we can do event time. Drop that in there. Please get everything done. And then I do have a little bit of experience with management, so I know I'm supposed to do or else. Director of Operations. Okay, so we just built that workflow. I'm going to save that. And then I'm going to come out here and grab a new SKU to add. So we'll copy that, pop over here. Let's clear this. Paste that in. So now we're adding SKU 2085. It's going to add it, raise the event. Now again, this has no clue that I just added this new integration functionality. But what happened is I get a little indicator here, and I get an email, and this is the integration that I just built. So that's a simple, what I'll call integration. That's just a workflow like that. What if we wanted to do something a little more involved? And I mentioned that I can upload an image, and I'm waiting for someone to verify the description of that image. So what would be cool is if I could take advantage of another Azure service called Computer Vision and have it guess at the description so I have a placeholder until I can verify that. So that's what I'm going to do in this workflow. I'm going to take an image, use artificial intelligence, actually machine learning, to figure out what the image is and describe it, and update that into the table that I have. So again, this is triggered from an Event Grid event. So we're going to pick that. And then the event that we drill down to is going to be the same thing. It's ignite the tour. The type of resource is a topic. The resource name is going to be inventory. And this time, the name of the event is called image set. So I'm going to use image set as that value. I'm going to do the next step, which is to parse the JSON for that. So we'll do parse JSON. We'll pick the parse JSON, and it's going to do the same thing as before. It's going to do the data, and then it needs a schema. So we'll come out here, and we're going to copy this schema. So this schema has two components to it. It has the SKU as well as the URL of the image that was uploaded. So let me paste that schema in. Now it's good to go. So my next step is to go out to Computer Vision. And what I want Computer Vision to do is describe the image. So I picked describe the image. It's asking me, where's this image coming from? Are you passing me a stream of an image, or are you just going to hand me a URL? So in this case, because I have the URL on the Event Grid message, I can just hand it the URL. And it can go straight into blob storage and pick that up. So I want to add a parameter of the image URL. That's going to open this up. So it says, where does the URL come from? Well, it comes from the Event Grid payload that we just passed. So that's great. So now it knows what image to look at and try to describe. So for my last step, there's no built-in connector for me to write to table storage, but that's not a problem because I can write a simple function, which I happen to do. And this function is called machine description. And what this takes, it's triggered by HTTP. It's going to read the data, and if it grabs a a description, it's going to update that description and update the table. So that's all this function does. It's just there to update that description. So to show you the integration for this, my next step is going to be Azure Function. So this is going to go out within my active subscription and look at all the functions. And this is Ignite the Tour, so there's a lot of people working on a lot of functions. Ours is going to be this Tailwind Traders inventory down here. So we'll pick that, and it looks at that function's host. Remember, I've already signed in, so it's doing this under my credentials. And I'm going to grab the machine description. And it basically just told me, you might get multiple captions back. Would you like us to go in a loop? So it created a for loop for me, which I don't mind. Now, what this is asking me is it says, you just pointed me to a function that takes a post, a request body. And it knows this because of the attributes that I set up. So what is that request body? So the request body is going to be a SKU and a description. So what I'll do is I'll come in and I'll specify, here's what the SKU looks like. And here's what the description looks like. And then I'm going to fill these in based on my payload. The SKU I can get back up at my Event Grid message. So I'm going to come down here to where I parsed the JSON. Let's go here. And I'm going to grab the SKU. The description is something I'll get back from the Computer Vision API. So remember I said every step, it's going to remember the elements of that step so I can drag them into the integration. Now, if you're curious behind the scenes, what's happening here, did I just overwrite something? Let me make sure that this is doing, it just closed out so it's got the captions tag. So basically, behind the scenes, this is generating a big JSON file. So I can develop these in JSON locally. I can check them into source control. I can put them into CI/CD DevOps. Same thing with functions. Everything you see here can be part of those workflows. So I don't have to do it from the designer. That should be the last step for this. So I'm going to go ahead and save this. And now this workflow should be active. So what I'm going to do is take that new SKU that I just added, and I'm going to upload an image for it. So this is going to basically paste the URL into the database, and then it's going to raise a message that we got an image. So it raised successfully, it says success. Now, what's nice about Logic Apps is after they've run, I'm going to come back to the overview. It'll give me a history of runs. And we can see that we just, was this recent? No, let's refresh this. There we go. So we have a successful run right now. And I can go into that run, and I can look at the various steps of the run. So I can see what did it parse out based on the schema, and it'll show me here's the URL, here's the SKU. I can ask it what happened when it called the computer vision API. It's going to give me an answer, and the answer it gave me was a close-up of a tool, and then it's showing me it successfully called the function endpoint. So if we go into our storage and we refresh, what we should see is right here a close-up of a tool. So it's added that description to the database for us, and it did that automatically. How was that for live integration? So it worked pretty well. Thank you. I appreciate it. And now we stop all the demos because they've been going well so far, and we don't want to ruin our luck. The other thing I wanted to point out is, what did I pass it? Well, I passed it this. And if you've done anything with machine learning, there's what's called trained models and untrained models. So computer vision out of the box on Azure has been trained over millions of images, but it's not every single image in existence. So it's going to do the best reasonable guess. In this case, it guessed correctly that it was a tool. If I'm a manufacturer who works with tools, what I could do is train the model, upload a bunch of different types of tools, and say, these are all hammers, these are all saws, these are all pencils. And then that trained model is going to be enhanced. And then when I run through and do this step again, it's going to come back and say it's a hammer. So it can be trained to do that, but that's a different talk and a different session for that. So that's what I wanted to cover with the serverless platform. I do want to show you just an overview of what this application looks like. This is one you can pull down, you can work with on your own, you can debug it locally. Durable functions and the functions runtime will both run locally for your application. I basically had a CLI tool that writes the blob storage and table storage. Table storage for the database, blob storage for the image. We raised events, and then that CLI tool is done. That's like my legacy application. I update it once to raise events, and then I forget about it. I had a workflow that comes through. I can do monitoring with, I showed you application insights, so the live telemetry. But this is kicking off the update for the description and the price and everything else, and deciding we can mark it active. I'd created an email integration as well as a vision integration as part of Logic Apps, consuming those different events. And we talked a little bit to machine learning just to show that this platform can integrate pretty seamlessly. I mean, that was live. I didn't have a pre-made demo for those integrations behind the scenes. This is where you can get the session presentations. This is where you can also get all the code that I just showed you. We've got about 5 minutes, and I know there's a reception, so some people want to go and party and celebrate how awesome this day was. But I'm going to hang out here for another 10 minutes. If you have questions, feel free to come see me. Thank you so much for spending your afternoon with me. Appreciate you.